Welcome to all of our educators. We are so excited to be able to share our research and our resources with you today for our soon-to-be released formative assessments within STEM. We are the SAM Labs education team, Mackenzie Meixner, Emily Deffenbaugh, Ashley Waring, and I am Jennifer Byram. And we were all classroom teachers that are so excited to be able to bring our experiences and learnings to our newly developed resources and our topic today, which is SAM Labs Formative STEAM and Coding Assessments. So with that, we're going to go ahead and jump right into today's objectives. In today's session, we are going to be exploring the research process that we took prior to developing our formative assessments. This is a resource that is going to be made available in time for back to school. We're also going to be exploring the importance of Bloom's taxonomy in education, and specifically how this hierarchy of learning was purposefully embedded into each assessment according to what research said was the best practice in order to maximize student learning and achievement. We're then going to be taking a deep dive into the framework and the structure of our K-5 formative assessments, while also looking at how these assessments can be used within the classroom in a meaningful way to help drive your instruction. And what we're really excited about is at the end of today's webinar, we're going to be able to provide you with additional materials so that way you get a better understanding and look at what these formative assessments will be looking like prior to their release, as well as providing you with some additional resources to be able to start formatively assessing student learning and track their progress in STEM. So before we get started, I really just kind of want to start off with why we chose to develop formative assessments. So when we first decided that we needed to develop assessments to go along with our STEAM course, we took into consideration the three types of assessments used in classrooms. You have, your diagnostic assessment, which if we think about it in terms of a sporting event, these are going to be the checks to see if you can pass the ball, if you can throw the ball within the goal line. These are the assessments on isolated skills to see where you are coming in at. Then you have your formative assessments, which are kind of like your scrimmage games to see where you are after your practices. So after you have those diagnostic assessments, you're going to be using that to help you determine where you need to start your instruction off at. After you start instructing, then you have these formative assessments. This is like that scrimmage game. You're going to continue in with that learning cycle or continue in with your practices until you get to that summative assessment, which if we stick with this sporting metaphor is going to be the actual game day against opponents, right? It's going to be what's actually measuring how successful were your practices, how successful are you in combining all of these skills together. We chose to focus our attention on formative assessments so we could ultimately provide educators with the tools to assess student learning during the learning cycle, so that way they can have their instruction informed and they can adjust that instruction along the way. So with that, we are going to start off talking about what research said is the best practice when assessing student learning and growth. So when it comes to assessments, it's most important to ensure that the tests measuring students' progress are both reliable and valid. And I'm sure for many of us, this is taking us back to those college of education days where you're sitting in your lecture and you have a professor telling you about reliable and valid assessments. In short, as a quick refresher, reliability is the degree to which the assessment being administered measures the same thing consistently and reproducibly, meaning the results are able to be repeated. While validity is the degree to which the assessment measures what it claims to measure. So are we actually assessing what we say we're assessing, or are we ultimately assessing what we're teaching, right? We've all come across and encountered assessments that are not assessing what their end goal is going to be, or are not actually assessing what was taught within the class itself. So ultimately, when developing these assessments, we want to consistently hit this imaginary bullseye. You can see those full examples down there, those 4 examples down there on the bottom of the slide, meaning that our assessments are both reliable and valid. So if you look at those 2 examples on the left side, you have that one where all of the little darts that were hit are kind of all over the place. They're not reliable and they're not valid. But then you have the one next to it where they're starting to come a little closer into the circle. So they're still spread all over the place. It's still not reliable. They're not hitting the same spot every time, but you are starting to get somewhat valid results because they're starting to come a little closer to that bullseye, a little closer to where you're trying to get to. Then if you look over at the examples to the right, we have that one that's not valid, but it is reliable. So all of those darts were hitting at the exact same spot. This person's able to reproduce the results consistently and multiple times in a row, but they're not getting where they need to be getting to. That assessment right there is not actually assessing what you're hoping it's assessing. What we want our assessments to do is to consistently hit that bullseye, so that way they are both valid and reliable. So knowing the importance of reliability and validity when developing assessments, this brought us to taking a closer look at how you can increase the reliability of an assessment. So the first thing to note is that it's important to conduct regular item analysis to weed out ambiguous assessment questions. So in the months that we were developing these formative assessments, we have peer reviewed each question multiple times, ensuring that each question and answer choice have gone through multiple iterations, ultimately making sure that the question is asking what we're wanting it to ask and what we're wanting it to assess, and that students are going to be interpreting that question the way we're wanting it to be interpreted. And we also currently have a test group that is utilizing a portion of these lessons so that they can provide us with feedback on the question and the assessment structure based on student data prior to making these available to our entire customer base. The next thing is that you need to ensure that there are clear and objective scoring rules provided for all of the subjective questions. So these are going to be your open-ended questions. And for each open-ended question that we have built into these formative assessments, we have provided exemplar student responses and a rubric-style scoring guide to ensure that student responses are measured using consistent and stated standards, right? So trying to take out some of that subjectivity and make sure that these more ambiguous questions that students are answering that are not multiple choice are measured using the same stated standards. It's also necessary to consider the length of the assessment. So best practice states that on a summative assessment, you want between 4 and 6 questions per objective. There's not really widely available research based on the amount for formative assessments and the number of questions to produce a reliable assessment. So because of this, we took the summative assessment standard and applied it to our formative assessments, ensuring that each assessment has 5 questions to determine student learning and growth within each lesson. Now, this isn't an end-all be-all measure, but it does allow us to get a quick temperature check to adjust in the moment or future instruction. So we took what research said was best practice per objective, and we applied that to our formative assessments per lesson to really help provide some reliable data to our educators about where students are at within the STEAM course. And then last but not least is that you need to make sure that external factors are being considered. And so this is your test fatigue, the familiarity with the assessment structure, among with other factors as well. So while developing each formative assessment, we made sure that we took into consideration the amount of time that each question would take, using research-based averages for various types of questions that were used to make sure that the assessments were kept within an appropriate amount of time. So our goal was about 10 minutes per formative assessment to make sure that students are not experiencing that test fatigue. So as mentioned previously, we currently have a small group of teachers implementing our formative assessments. So we can continue to monitor these formatives, taking their results into consideration into the coming months prior to making them available for back to school. And so once reliability was factored into our assessment development, we turned our attention to validity. And this quote that you see here really sums up the importance of valid assessments and how to ensure that the assessment being administered is valid. And so it says instructional assessments should be curriculum referenced, directly reflecting the content children are learning. The alignment between curriculum and assessment is an essential feature of assessment to inform and monitor instruction. So ultimately, we want to make sure that the assessments we are administering to our students actually reflect what we are teaching within the classroom, so we can correctly inform student learning and student growth, and then also inform our instruction going forward. And so throughout the process of ensuring that we developed these curriculum referenced assessments, lesson objectives were considered. So we made sure to deep dive into each lesson that the assessment was being created for, so that those specific knowledge and skills covered within the lessons were built into the assessment. So we could ensure that the assessments being written were curriculum referenced, and anything assessed for students comes directly from learning that they will have received within that lesson. But while doing this, we also unpacked each standard to determine the content that students needed to understand and the way that this knowledge was to be displayed. So we know that quality curriculum is always going to be standards aligned. So as we were going through and we were writing these assessments and taking that curriculum referenced approach, we also made sure to have those standards sitting right next to us, and we had them unpacked to know that content and the way it needed to be displayed to show mastery of that skill right next to each other. So ultimately, this resulted in an iterative process where the assessments were aligned to the curriculum and the standards, while the curriculum was also being adjusted to ensure even tighter alignment to the standard and the assessments. So you can see here that example where it really was just an iterative process where we continued to modify the curriculum and the assessments to make sure that not only are they tightly aligned to each other, but that they're tightly aligned to those standards that we are wanting to assess our students in. And so now that you're familiar with the research that went on behind the scenes in the months leading up to developing these formative assessments, we're going to take a deeper dive into one part that was fundamental into the framework of our assessments, which is Bloom's taxonomy. So again, taking you back to your College of Education days, I'm sure we all remember seeing this again as we were sitting in that lecture hall. Bloom's taxonomy is ultimately just a hierarchy of learning, which was developed to provide teachers with a framework to plan challenging lessons, ensuring that student success and progress was being maximized each day. So what's important to note is that each layer is going to utilize and extend skills from the previous layer, meaning that students need to master the ability to remember and understand before they can apply, analyze, evaluate, and create. By using this structure, students are encouraged to think critically, using different thought processes that allow them to deepen their learning and consider other perspectives and alternatives. So this is something that Bloom termed mastery learning, which is something that as educators, we say we aim to do, which is to teach towards mastery. And Bloom's taxonomy is a way to do that. So with that, we then started researching even further. If you go to the next slide, Mackenzie. And what we started to think about is that if our goal is to teach towards mastery, then as educators, we need to make sure that we are providing students opportunities to think critically and to engage with these different thought processes. So we started to research what studies say is best practice for integrating and embedding Bloom's taxonomy into classroom instruction and into assessments. So studies have shown that student learning gains are increased when students engage with an appropriate number of higher order thinking questions. So it's important to note that basic remembering and understanding is important to increase these learning gains, as the same study showed that the increase in learning gains were most noticeable when students engaged with questions from all levels of Bloom's taxonomy. So you need to make sure that students are being asked to remember and to understand, again, to make sure they have that basic understanding. But then once they have that basic understanding, to extend and to deepen into those higher levels of Bloom's. So ultimately, it laid out a basic guideline for assessments and classroom discussion questions. So it said that approximately 20% of the questions that lower elementary students engage with should be these higher order thinking questions to push and extend students' learning and thought processes in order to maximize student learning gains. While approximately 50% of the questions that secondary students engage with should be higher order thinking questions. So this left us with understanding for the lower elementary students and then also those middle school and high school students, but not much research was provided for our upper elementary kiddos. So with that, with there being little guidance on upper elementary, we used that 50% measure for our 4th and 5th grade assessments in order to prepare them for that transition to secondary education. So before we get into the framework of each assessment, I want to highlight the way that Bloom's was purposefully embedded into each of these formatives while prompting students to utilize those different thought processes. So you can see here that we have a kindergarten and a 1st grade example. Both of these questions fall under the analyze tier on Bloom's, but each question is asking students to use different skill sets. So the kindergarten example has students recognizing patterns to determine possible outcomes, while the 1st grade assessment has students analyzing various materials and then classifying them based on their properties. So while we have created 2 questions that fall under the analyze tier of Bloom's, one is asking students for pattern recognition, while the other is asking students for classification. So here you can see we were purposeful in making sure that while we were writing these assessment questions, that the stems were not the same all throughout. Instead, we're encouraging students to practice all of these different skill sets as they're working through and as they're growing through the SAM Labs curriculum. Then we have that 2nd and that 3rd grade example. So both of these are falling within the evaluate tier of Bloom's, but you can see that the 2nd grade one is asking students to draw conclusions. So here students are going to be asked to basically make inferences. They're provided with a situation and they are having to take their background knowledge to marry that with the situation that's being provided and then draw conclusions based on the likelihood of an outcome. While the 3rd grade one is providing students with a situation and it's then asking them to critique these 3 different options to determine which is the best solution for the challenge that they were presented with. So again, 2 different questions falling on the level of Bloom's, but one asking students to practice the skill of inferencing and drawing conclusions, while the other is asking students to critique different possible solutions. So which then brings us to 4th and 5th grade. So for our 4th grade examples, students here are presented with this scenario and then asked to apply their scientific knowledge to interpret the reason behind the events. So this is going to fall on the analyze level of Bloom's, but this is going to use the thought process or routine of interpretation. So our previous examples of analyze had students practicing pattern recognition and classification. So again, you can see various thought processes being used and embedded throughout each assessment, even within the same level of Bloom's. While our 5th grade example is another evaluate level question, but this time students are asked to practice the skill of appraisal compared with our earlier examples of drawing conclusions and critiquing. I wanted to highlight these examples to show you the purposeful way that Bloom's was embedded in each assessment, including those various different thought processes being practiced. So that way we are giving our students exposure to various types of questions and ways to show their thinking and learning. So now that you have kind of that understanding of why we created these assessments the way we did, the research that went into it, now I'm going to pass it over to Emily so she can go into the assessment framework.
Thanks, Jennifer. Okay, so as we all heard from Jennifer, we took a very detailed approach on how we wanted to set up our grade level formatives. So we're going to go ahead and look at the next slide so we can see that our framework includes 4 overarching areas. And we begin with aligning all of our NGSS and CSTA standards for that specific lesson. We then couple that with a variety of higher order thinking question stems and prompts to see if the students can actually apply the concepts from the warm-up, the let's build, the coding, and the debugging portions of each of our lessons. Now, those first 2 aspects up at the top pair together actually create the structure for the assessments. The third portion down at the bottom of our framework includes ensuring that we have provided possible student misconceptions, as Jennifer mentioned, as well as exemplar samples when the students respond to an open-ended question or a drawing prompt with annotation. And finally, the last portion of our framework considered the actual build itself. So where the students were able to work through the design process to create their own working model or prototype. Now, these bottom 2 aspects work together when analyzing student responses and considering their progress on the coding and prototyping rubric. You as a teacher can see more precisely where the student outcomes are and therefore design your next instructional steps accordingly. One thing I want to mention here is that I will go more in depth with the rubric and progress monitoring option after we go through some samples of the formative assessments with the different grade levels. So that's where we're going to head next. As you may know, using our STEAM course, our lessons are designed for kindergarten all the way through 5th grade, but do take on 2 different structures. So we aligned our assessments to be similar to the same structure of the K1 and of the 2nd through 5th. So we're going to first begin by talking about kindergarten and 1st grade assessment breakdown. And as you can see here, we have 6 different components that are featured within each of our assessments. We're going to take a closer look on the next few slides of these 6 features. So to begin, you can see that we have visual cues next to each question for easy student tracking. This allows students to follow along with each question, helping to keep them on task, as well as to limit possible mistakes due to misalignment while they're answering. Teachers can prompt their students to put their finger on the tree or the owl, etc., so that the students know where the teacher is reading, they can follow along, and they can understand how to respond. Now, depending on the question type, there are going to be clear visual representations for the expected answers. So that includes large boxes with large handwriting lines when the students need to draw or label, larger answer bubbles, and additional visual cues within the questions themselves, such as circling the word circle or bolding key phrases. Answer selections for the kindergarten and 1st graders are also in larger, bolder text. We wanted to ensure that the focus was on the students' knowledge of actual science and coding, not the reading comprehension or writing abilities. And finally, you may note that we've included, a variety of question types like drawing, multiple choice, matching, and labeling that range in difficulty. And they're generally for each of the lesson assessments going to be split up where we have 3 questions based off of the NGSS science standard, 1 question based off of the NGSS engineering standard, and 1 based off of the CSTA coding standard. Again, they're going to be all varied levels of higher order thinking, where they may just start with demonstrating and basic identification, but it could be all the way up to complex analysis. So the last thing I would like to share for kindergarten and 1st grade is the matching answer key, which you can note that each question is going to be labeled with the matching standard for easy identification of tracking data and growth. Each question's correct selection is clearly marked, whether it's an answer bubble filled in or a description of what the student should have written or drawn. Now for the open-ended questions, sample exemplar responses have been provided as a guide as you go to analyze their responses. Additionally, as mentioned before, each answer choice will have that corresponding possible student misconception so that you can plan your lesson accordingly based off of how the student answers. Now, one feature that makes kindergarten and 1st grade assessments different are going to be the provided teacher directions. So Mackenzie's going to skip over to the next slide for me. Thank you. And we realize that students are just at the foundations of learning to read. So we want to be able to provide explicit, clear instructions so that the students can follow along as the questions are being read aloud. This also links back to what Jennifer mentioned earlier about validity and reliability. Furthermore, we want to again stress that the question should assess their science and coding knowledge, not their reading abilities. The directions are easy to follow in a guide, with the bold text being read aloud, followed by each question having clarification statements to help aid in comprehension. We've also included a few tips because, of course, working with primary students may require alternate ways to administer assessments, as you know, they're 5 to 7 years old. Moving on to our 2nd through 5th grade model, you're going to get to see the breakdown again that there are 6 different components that are featured with each lesson. Some are the same as the K1 section, but there are a couple of different ones. So let's take a closer look in these next few slides. Perfect. So our 2nd grade level is a little bit different from the 3rd through 5th. It's a little bit more complex than the K1, as you can see. There is a subtle difference where there are still visual prompts and larger text than there will be with the intermediate grades, but it does have a slightly higher level of complexity. Now, depending on the question type, there are still clear visual representations for the expected answers, including boxes and handwriting lines, like I mentioned before, where they need to draw, label, fill in answer bubbles. And they also have additional visual cues for the 2nd grade level, including things like underlining and bolding key phrases. Answer selections here are still larger in bold text with images that accompany all the coding questions to help aid in comprehension. Now, we again have included a variety of question types, even for 2nd through 5th grade, like drawing, multiple choice, matching, and labeling, all again range in difficulty. But this time the question breakdown is generally going to be split where there are 3 NGSS science and engineering questions, and this time there are 2 CSTA coding questions, and again, all ranging in levels of different types of thinking. If we move on, the matching answer key is going to be similarly set up just like the K1. You'll note again that each question is labeled with matching standards for easy identification for tracking data and growth. And again, just like the K1 assessment keys, each questions will have a correct selection clearly marked, whether that's the answer bubble filled in or a description of what the student should have written if it was open-ended. Again, for those open-ended questions, you're going to see the exemplar responses to help provide as a guide as you go through and analyze their responses. Additionally, with the 2nd through 5th grade assessments, we've also included point values for those open-ended questions. And this may help guide as you're creating your flexible groups. And if you choose to score assessments to see where the students fall within that data. For example, if you have a PLC team meeting every week and you're pulling data, you may want to be scoring these, not necessarily for grades, but for discussion and analysis. And again, here the answer choice has a corresponding possible student misconception, so you can plan your lesson accordingly based off of their responses. Now, moving into our 5th grade level, you'll see that we've jumped right up to the intermediate grades, and it's only, though it's only still 5 questions because formatives should be quick check of their knowledge, but the questions are layered in a more complex yet similarly structured way that the kids are used to seeing in other testing formats. So depending on the question type, they'll still see clear visual representations for the expected answers, again, including boxes and handwriting lines that are more appropriate for the older intermediate students. And you'll notice that the answer bubbles here are smaller. It's more developmentally at their age level. There are no additional visual cues within the questions to aid in comprehension here, but there are opportunities for students to practice their visual analysis. We have questions that include tables, graphs, image analysis, etc., where they will have to look at the visual data to be able to apply their knowledge that they used from the lesson. And we've also still, again, included a variety of question types. It's not all multiple choice, which we often see once we start hitting intermediate grades. And again, they're all going to range in difficulty. And just like the 2nd grade, we've made sure that we've included 2 questions focusing on the coding and 3 questions on both the science and engineering. For our matching answer key, it's all the same features as mentioned before with the previous keys, with one additional note that I wanted to point out. Here, the student exemplar responses have been provided in a black font, and the misconceptions are in teal underneath. So you can see the easy differentiation when you are reading through the answer key. So as mentioned before, we're using these formatives in all different kinds of ways to help us figure out where our students are with the specific standards in the lesson. But it's not just all about answering questions. It's also about what the students were able to produce as they went through the challenges to code. So to accompany the specific lesson formative assessments, we've also designed a SAMLab specific coding and prototype rubric that can be used in a few ways. So first, if you go through the rubric with your students beforehand, before going through these lessons, the kiddos will understand the expectations of each attribute, sorry, just lost it, they'll understand ahead of time, and they'll be able to set goals and plan out action steps to either meet or exceed those goals. So this may take several attempts as they work through all of the different tasks and challenges through the design process. We've also created an editable progress monitoring sheet that you'll be able to, or they will be able to track their own progress. Secondly, of course, you can use the rubric to grade final prototypes at the end of challenges. The attributes here are specific to the lesson breakdown in our STEAM course, which Mackenzie's going to go through a little bit in depth in a few minutes. And we've also adapted one for 6th through 8th grade, because we know many of you middle school teachers are using modified versions of our kindergarten through 5th grade STEAM lessons. So we wanted to make sure we had a rubric available for you as well. Now, if you were able to join us in last week's webinar regarding assessments in STEM, this is an additional STEM rubric to the 21st Century Skills one. If you were unable to join us, you can still access that 21st Century Skills pack by clicking on this link that you see on this slide when you get your copy of this presentation. Now we're going to see how the coding and prototyping rubric is segmented across the grade level bands. So to the left, you can see our lesson structure breakdown for each grade level band. And as I mentioned a minute ago, Mackenzie's going to go more in depth with this in just a few moments. But the rubrics have been structured based off of this breakdown of these lessons. So as you can see, for kindergarten and 1st grade, students can earn up through proficient in explore and create, coding, and application of knowledge when they reform as a whole group back in the plenary. Now, the students, as they progress into 2nd through 5th grades, the option for acceleration is added to the rubric, and the attributes include learning from the teacher-guided Let's Build, planning and tackling the challenges, and their ability to problem solve through debugging. Now, though the STEAM course is completed by 5th grade, we know, as I mentioned before, that there are many teachers out there that modify the lessons with their older students as well. So again, we do have a 6th through 8th grade rubric similar to the intermediate rubric. We've just added a level of complexity within each attribute. You will get to have a copy of the rubrics, both the teacher and student versions, as a thank you for attending our session today, in addition to this presentation that will include links of the separate resources. Now I'm going to hand it off to Mackenzie, who's going to go more in depth with how you can utilize formative assessments in a meaningful way in your instruction.
Thanks, Emily. All right, so hopping into the application of these formative assessments, we are going to start with K1. So as Emily mentioned quickly, the lesson structure for our kindergarten and 1st grade lessons is different than our 2nd to 5th grade lesson structure. And therefore, how you would use the formative assessments in K1 will also be different. So just quickly to explain it in a nutshell, we do recommend splitting up the K1 lessons across 3 days. And specifically, day 1 is going to be that content-rich day where you're gathering your students, having them at the carpet, you're going through the warm-up, the mini lesson, the keywords and tier 3 vocabulary for that science standard, and then also kind of getting kids engaged with a shared reading passage about Blocky and his problem for that lesson. After day 1, you're kind of moving into day 2, and day 2 is all about getting hands-on with the SAM blocks and in the coding platform. And so for K1, it follows a station rotation where students are spending about 10 minutes at the Explore, 10 minutes at the Create, and 10 minutes at the Code stations. This is more developmentally appropriate for our younger kiddos, so they're able to get out of their seats and move around and really kind of tinker and explore with different hands-on materials, as well as kind of go through a code with the teacher at that station. And then the 3rd day is where students kind of come back, whole group, and they apply all of their learnings from each station in a plenary. And so they're bringing everything that they learned from the Explore, where they kind of consolidated their science learning in a real world scenario. Then they're bringing everything that they created from the prototype to the code with the blocks. And they're kind of bringing it together full circle, and you're concluding the lesson itself. But that's where you see the formative assessment fitting in. So after you conclude the lesson, you are taking your time and walking students through that formative assessment, which concludes this 3-day cycle of the K1 lessons. So you'll see that day 3 is shorter. There's just the plenary and the formative assessment. But with that being said, the formative assessments are going to take a little longer with our younger kiddos, since you are reading the questions to them and kind of guiding them through the process. So below, we just wanted to highlight some best practices when you are implementing the formative assessments with your kindergarten and 1st graders. So first is just to make sure to remember to prompt students to use those visual cues so that they are tracking each question as you are going. This will just allow them to not get lost in all of the text on their worksheets, but be able to follow along and read along with you as you are going through the assessment. Second, you can choose to conduct the formative assessments either whole group, small group, or one-on-one. Now, ultimately, that depends on whether or not you have another adult in the room or a co-teacher. You could split the class in half, or you can choose to do it whole group. But either way, we've set it up so you can choose to do it how you see fit. And the third best practice here is to use those teacher directions. So Emily quickly referenced them, but we will have them available for you for the kindergarten and first grade formatives. And basically, they just kind of guide you through the process of implementing that formative with your students. There's bolded text that is actually what we would encourage you say out loud, but then there's also some other kind of pieces of advice or notes to share with students as they are going through the formative assessment. Now let's move to 2.5. So our 2nd to 5th grade STEAM content is different in the modular structure. So it does follow this modular structure that walks students through kind of everything from the warm up to the exit ticket at the end. Now you can see on the picture to the left, the modular structure, again, is broken down by what we would recommend you break up that SAM-Labs lesson into. So you can break it up into 3 days, where now we're using the formative assessment in a different way. So as students in 2nd to 5th grade are getting into those testing grades, we wanted to make sure that how they are using these and how you are using these formative assessments actually informs, how you're instructing your students to ensure that you're filling those gaps so that they are walking away consolidating their knowledge. So what we've done is we've actually broken it up where there's a pre-assessment, and that pre-assessment is just the formative assessment, but given at the very beginning. And so how you would like to give it is up to you. Maybe you want to use it on day 0, even before you jump into that SAM-Labs lesson, so that you could take that night to take a look at the student responses to then inform what your mini lesson is going to look like when you do jump into the SAM-Labs lesson. So you could do it that way, or you could do it on day 1 and continue on with your instruction as normal. But then maybe you want to take a look after day 1 and do a small 10-minute reteach when you jump into day 2. So it's up to you and kind of what you would like to do with your students, but we do recommend using the formative as a pre-assessment where you're giving it to students, they're taking it independently, but ultimately you're not going over the answers with them, right? So you're just taking a look at it and it's informing your instruction. So then you go through the warm-up and the mini lesson and that tier 3 vocab in day 1. And when you go into day 2, it's getting those SAM blocks, getting into the coding platform, and you're working through the Let's Build, the Challenge 1, where students are working in their small groups to try to kind of extend that code, and then they're going to move into the debug it. At the end of day 2, they're moving into day 3, and day 3 is all about extension. So they're kind of going into Challenge 2, extending that content further, extending their code and using their blocks again, and then moving into the Chili challenges and reflection. And there you see at the end of day 3, we are looping in that post-assessment, which again is the same formative assessment for that lesson. But this time you're going to collect it and you're going to use the student responses to inform further instruction outside of the SAM-Labs lesson. So just some best practices for the 2.5 formative assessment implementation is to, 1, again, just make sure that you're using the formative assessments to adjust your instruction to purposefully, address either the science standard or the coding standards within that lesson. So maybe your students are all set on that science standard, but they're struggling with the coding knowledge that they'll need to successfully build the system for that lesson. So maybe you want to take more time on explaining the function of what a light sensor does. All different purposes are up to you and what your students are actually, what you're seeing from the formative assessments to inform moving forward. The second best practice is around the how long the assessment should take. So I know there was a question in the chat about this. It's a great question, but for 2.5, the formative assessment should take no longer than 10 minutes. So it's 5 questions. Again, some of them are higher order thinking, some of them are not, but it should take no longer than 10 minutes. And lastly, the post-formative can act kind of as an exit ticket. As I mentioned, it can inform your instruction outside of the SAM-Labs lesson and can be used as a completion grade. Now, one thing I will mention kind of moving forward, we will be developing summative assessments, as Jen mentioned at the beginning of the presentation. And those summative assessments will be different from our formatives because we will have 2 different forms. So we'll have Form A at the beginning of a SAM Labs unit. Before you do any SAM Labs lessons, you can give your students the summative SAM Labs assessment. And then we'll have Form B, which will differ in questions, but still cover the same standards. So we're able to truly grade and track how students are doing. All right, so now we're gonna have a little fun and we're gonna jump into a couple case studies of essentially how you would use these formative assessments to kind of monitor your instruction and based on the student data that you've collected. So I want you all to kind of step into the shoes of a student, because I'm gonna ask for some engagement here and I'm gonna ask for you to respond in the chat. But we're gonna take a look first as if I were using the SAM Labs lessons for science instruction. And specifically, we're going to look at this 5th grade Earth space standard, where students are supporting an argument that the differences in the apparent brightness of the sun and comparing it to other stars due to their relative distance from Earth. And so you can see a snapshot of our 5th grade rocket lesson. And the question is, which of the following statements about stars is true? A, smaller stars are always brighter. B, the smaller a star appears, the closer it is to Earth. C, the brightest star in our galaxy is Sirius. And D, the smaller a star appears, the further away it is from Earth. So I'm gonna shoot over to you guys, my students in this little case study. Go ahead and share your response in the chat. I'll give you 30 seconds. Nice, I see the responses coming in. Take about 10 more seconds. So I'm gonna be cognizant of time. All right. So basically, this is what the formative assessment question may look like. But let's say in the table to the right, this is what your student data looks like. So you have students kind of all over the place here. You know, one student thinks that A is the correct answer. You have 10 students who think that the smaller a star appears, the closer it is to Earth. And then you have students spread out. So now let's discuss, okay, what do I do with this data if I were the teacher? Well, what we're going to use is the formative assessment answer key to really look into what that misconception is, what's going on in my classroom. And the reality is that because 14 out of 19 of your students got this question incorrect, you're probably going to want to do a whole group reteach. But let's take a look at what the main misconception is when it comes to this question and this standard. So most students answered B, and that students have a limited understanding of how proximity or distance affect the apparent size. And so you can kind of use that as, okay, this is what my students are struggling with, and that can be your target for your reteach, and so that you can discuss with students how the brightness of a star is dependent on its proximity to Earth. So for those of you that said D, nice job. And we're going to jump into one more case study here, and this is going to be around a coding standard. So maybe we want to focus on coding and seeing how our students are doing and tracking that. And this is a K2 standard around the iterative design process as students are building a system. And you can see a snapshot of our lesson on an earthquake, where students built an earthquake simulation. But this question is specifically saying, if we modified this system and attached the DC motor now to the toggle, how does that change the effect of the DC motor? So students are having to apply this. So again, you can just correspond to A, B, or C, and you can read the answer choices, and you have 10 seconds to get your answers in. What do we think the answer is? Will the DC motor continue to spin? Will the DC motor only spin when the S key was pressed, or the DC motor spin at the set interval? Let's see our SAM Labs pros out there. All right, final couple of seconds. All right, so let's now kind of imagine that this is the student data that you collected. And here you can see that 13 students said that the correct answer was A, that the DC motor would spin without stopping. 5 students are thinking that the S key would still need to be pressed in order to power the output of the DC motor. And then 1 student thinks that the DC motor would spin with the interval. So getting a drum roll for the final reveal, the correct answer is A. And so with this student data, there was a small group of students that just struggled with the S key and understanding specifically the purpose of the toggle in this system. So in this case, it would just be a small group reteach, maybe while other students are working on an extension or on the Chili challenges. And you're just pulling students aside and walking them through the purpose of the toggle in the system and the fact that it keeps the system on. We don't have to hold in that S on our keyboard to power the DC motor. So that was just a quick little fun activity walking you through how you can use not only the formative assessment, but also the answer keys with those misconceptions structured out for you to ultimately reteach and support your students' learning. So now I'll jump into one final resource that we have along with our formative assessments, and that is the assessment item bank. So this is actually what you're going to walk away with today. And the assessment item bank is a tool for teachers to see the assessment questions by standard across all of the lessons within a grade level. So each grade level has an assessment item bank. And it's really useful because you're able to see the variance in the types of questions that are asked by standard. So if you think back to all of the Bloom's taxonomy and how we were making sure to cover different thinking skills, this gives you a quick snapshot into all of those thinking skills by standard. So you're able to glance over also which lessons are covering specific standards. So if you look at the snapshot to the right, we have the engineering design standards for 3.5, but you can see that that's the same standard, but the questions and the thinking skills from lesson 2 to lesson 5 are different. So it's just kind of showing you what the questions look like, as well as the answer key and misconceptions there. The last thing that I think is super useful with this is that teachers have now a clear vision of the types of questions students will be assessed on across the grade level, across all of our SAM Labs lessons within that grade level, and the misconceptions that they might be bringing into your lesson. So that will just help you inform your instruction so that you're covering those misconceptions before they happen. So this is what you'll be walking away with today, a sample pack of the first and third grade assessment item banks that cover a variety of standards from the science, computer science, and the engineering design standards as well. And with that, you're probably wondering, well, how do I access these formative assessment packs? So these formative assessment packs are part of our new SAM Labs Pro subscription plan, which actually will be fully released in fall 2021. So we're going to be releasing the formative assessments in a printable PDF version to start with. And in December 2021, these formative assessments will be interactive digital assessments built into SAM Studio, along with student reporting so that you can collect that student data directly within the coding platform. So you can see some screenshots of kind of what we're working towards. But the last thing that we will mention as well is that along with the interactive lesson builder, so that means that you can write your own lessons within the platform, there's going to be kind of the opportunity to create your own, not only lessons, but custom check for understandings for each lesson that you do with your students. And so with that, we will kind of wrap it up as we are kind of over in time here, but thank you all so much for attending. And if you want more information, we shared the link in the chat of what this SAM Studio Pro is going to look like and all of the features, and we'd be happy to chat with you further about it if you have any questions about it, what it would look like with your students.
Wonderful. And Mackenzie, if you would skip ahead a couple of slides for me. Just wanted to show a reminder. You all will be getting a copy of this slide deck with all of the links to be able to check out the rubrics that Emily mentioned from our previous webinar. But I also wanted to draw your attention to the appendix today and these sample resources. So under the sample resources, you will also find our SAM Labs prototyping rubric. Again, this is that PDF document of the teacher and student pack for our K1, 2, 5, and then 6, 8 prototyping. But also a couple of additional resources such as our project monitoring sheets that you can be used with the rubrics to be able to track student progress, and then just a couple of other resources for setting goals, and then a couple of Education Week spotlights on assessments in STEAM particularly. So as Mackenzie said, thank you all so much for joining us, and be on the lookout in your email for a follow-up after today's session with the slide deck and then your sample assessment pack for some of the first and third grade standards. If you have any questions, feel free to just go ahead and drop them in the chat for us, and we will answer them as they come in as we wrap up today's session.